Hello everyone, my name is João Rafael Gregório. It is a pleasure to be here in the 2060 International Conference on Enterprise Information Systems to present part of the work developed in the ACME Cybersecurity Research Laboratory coordinated by Professor Dr. Adriano Mauro Cansian. The work, whose title is Deep Convolutional Neural Network and Character Level Embedding for DGA Detection, was developed by me during my master's degree in computer science at São Paulo State University, UNESP, Brazil, with the co-authorship of Professors Adriano Mauro Cansian, Leandro Alves Neves, and Denis Henrique Pinheiro Salvadeo, to whom I thank for their partnership during this research and realization process. Who are DGAs? DGAs are algorithms present in malware used by botnets and advanced persistent threats that generate domain names in a pseudo-random manner that are used to maintain and obfuscate communication between the infected client and the attacker's command and control server. This strategy also serves to evade security layers, as communicating using a domain name allows the attacker to change the IP address of his command and control server without the client losing contact with him. This puts the strategy of blocking reported IPs always one step behind attackers. Below, we can see some examples of domain names generated by no threats. This figure helps us better understand the functioning and use of DGA domains in operating a malware or botnet. When a client infected with malware needs to communicate with the command and control server, instead of directly using the server's IP address, it generates a domain name based on a rule. Previously, the attacker has already registered compatible domain names with registrants through the internet. The malware will generate a compatible domain name and request the resolution until there is a positive response and the communication with the command and control server is established. Therefore, the objectives of this work are: indicate the use of character-level embedding as an effective strategy to improve DGA detection, results in deep neural networks architectures. Describe how the combined use of ReLU, max pooling, and embedding layers can improve the results and performance of convolutional neural networks in detecting these DGAs. And present a deep neural network architecture with competitive results in detecting DGAs without feature engineering. To develop the experiments, two datasets were used. For examples of legitimate domain names, we used the 1 million dataset provided by Majestic Million, a well-known public database. For DGA's domain name examples, we use a dataset provided by NetLab 360. with around 1 million examples from 56 threat families. This dataset is also well known and widely used by the academic community, despite NetLab 360 having discontinued the open provision of this set in 2022. As a complete schematic of model would be very large and perhaps difficult to understand, we have a conceptual model of Model 1, which is the proposed complete model. The input vector is nothing more than the domain name converted character by character to its respective ASCII code up to the range of 70. Domain names with fewer characters are completed with zeros from the end, and larger domain names are converted up to the number character 70. This vector is then delivered to an embedding layer. Embedding is a feature widely used in natural language processing to encode words, transforming each word into a fixed size vector. In addition to coding, embedding layers are capable to establishing relationships between words. So embedding is widely used for sentiment analysis, for example, in natural language processing. In our work, we use character level embedding. So each character of the domain name is encoded into a vector of 20 values in order to establish the relationships between each character in a given domain name. If we remember that the domain names of DGAs are generated by an algorithm, in practice, we are trying to understand how this algorithm works without having access to it, but having access to the domain name generated by it. The embedding vector is then fed into a convolutional neural network structure. Convolutional neural networks are commonly used in computer vision to extract features from images. This structure relies on a series of convolutional layers, ReLU and max pooling, in order to extract relevant features from the vector provided by the embedding layer. The meta features extracted by the convolutional framework are finally delivered to a dense classifier that will culminate in a sigmoid output, a value between 0 and 1, where the closer to 1, the greater the probability of a domain name being a DGA. As the closer to 0, the greater the probability of it being legitimate. As one of the initial objectives is to observe how and how much character level embedding can contribute to detection of DGA domain names. We created two other models to compare the results obtained. Model 1 is the complete model with CNN, embedding, ReLU, and max pooling layers. Model 2 has been changed on the convolutional structure by removing ReLU and max pooling. And the Model 3 has been changed by removing the embedding layer. Here, we can see the complete experiment process in 3 steps. In the preprocessing stage, domain names are encoded to ASCII, and legitimate and DGA labels are encoded to 0 and 1. In the sampling stage, 20% of the dataset was separated for training the models, and 5% samples were selected from the rest to test the models after training. Therefore, each of the models were trained and tested with the same examples, and then we averaged the analysis obtained by each of the models across the 5 test sets. The results are summarized here. Model 1, complete with all layers, obtained an average precision of 99.33%, average recall of 98.93%, average accuracy of 99.12%, and a false positive rate of 0.68%. The model 2, a model where the convolutional structure was changed, removing the ReLU and max pooling layers, obtained an average precision of 98.34%, an average recall of 97.76%, average accuracy of 98.04%, and a false positive rate of 1.68%. So we see that the ReLU and max pooling contributed around 1% in the overall metrics. Model 3, the model without the embedding layer, obtained an average precision of 95.91%, average recall of 91.33%, and an average accuracy of 93.66%, in addition to a false positive rate of 3.96%. It can be seen that removing the embedding layer had a significant impact on the metrics. In conclusion, therefore, character level embedding improved metrics by about 5%. The combined use of character level embedding and ReLU plus max pooling guaranteed a false positive rate about 6 times lower. And the model 1 proved to be robust, with results aligned with the results of the most current students in the same direction. For future work, we can suggest approaches based on transformers, perhaps specific approach to certain threat families, as the heterogeneity of families can make detection difficult. More approaches based on natural language processing, possibly using more data related to domain names, such as whois, for example, and semi-supervised or even unsupervised approaches, and integrations with passive DNS, working with data collected in the real world. The complete experiment with the dataset and algorithms is publicly available on Kaggle. Feel free to reproduce and evolve the experiment. Thanks for the CAPS coordination for the improvement of higher education personnel in Brazil, CNPq, National Council for Scientific and Technological Development, and the .br Information and Coordination Center, niki.br, for partially financing this research work. This is all reference used in this work. If you are interested to contacting me, are my email address and the address of ACME Cybersecurity Research Laboratory page. Thank you.